Welcome to the Palisadoes Foundations Calico Challenge presentation for the insite Scrappi open source project. For those of you who don't know, the Palisadoes Foundation LLC is a registered 501c3 nonprofit organization registered in California. It was conceived by a group of Jamaican technology professionals interested in assisting in the continued development of new and existing technologies in Jamaica. Our principal activity is the Calico Challenge, where each year we sponsor summer internships for university students studying in Jamaica. The students work on developing open source projects under the guidance of a professional mentor. Stipends are paid upon achieving predefined milestones. The Scrappi project is one that you're about to see and has Abbagay Richards and Chen Shui from Medullan, a Jamaican company, mentoring a postgraduate student, Dominic Mills. Scrappi is a part of the insite suite of projects aimed at storing and charting data from various computerized sources. Uh, Dominic, over to you.
Thank you very much for your introduction. Now I will describe the work I've been doing over the past few months. So, as was previously mentioned, I've been working on the Scrappi challenge for the Scrappi project for the Calico challenge, and it's, as the name suggests, a web scraper. So some basic features of this web scraper would be that it should be able to scrape from a number of different websites, curate the data by HTML tags, a feature to search through scrape data. Now, I scheduled the scraper to scrape at regular intervals. Now, initially, I had planned for some of these features to be more abstract and generalized. So in the sense that I didn't necessarily have I had planned in mind to scrape from HTML tags, but DOM elements and JavaScript elements as well, and CSS elements as well. But what had happened was that I realized that when you're building a general purpose web scraper, that these features themselves are quite involved in terms of you really don't know necessarily what your JavaScript element is going to do, and certain actions that you take can necessarily change. So it becomes quite complex really quickly if you try to do it in a very general way. So I decided to restrict the scraper to just HTML tags for now, and then leave it as, say, some kind of future development project to see if this can be more abstracted towards CSS elements and JavaScript tags as well. So this was my first major project with Node.js, and I had extremely limited exposure to Node.js prior to joining this program. Initially, it was a very steep learning curve for me due to the asynchronous nature of Node, and for me, I was used to these kind of imperative languages before, because I'm not necessarily a programmer per se. I'm a mathematician who has prior experience in programming. So this whole asynchronicity of Node in itself proved to be, required me to kind of change how I previously thought about things, and things that were pretty much trivial for me previously were really quite involved now since I started working with Node. So when working on the first milestone, the multiple hosts, I had a lot of difficulties using the then syntax, which is a type of functional way of requesting data. Well, in my situation. So this functional approach to handling asynchronous code was extremely intuitive for me, and it took me a lot of time to kind of figure out, how to access data, because I'm more used to thinking of things in a more imperative way. And this whole notion of promises and such kind of really threw me off initially. So what the real difficulty lied in the fact that I wasn't necessarily sure how to manipulate data as a type of intermediary, in the sense that if I requested data from a single website, would it be possible to catch it in a way and then save it somewhere, store it in some variable, and meanwhile continue with some other processes and do that. So this was my original code for the scraper, and as you can see, the two thens affixed to the code are really they're not pleasant to look at so much, and it kind of obfuscates the code. So this code was scrapes a single website page, and this code scrapes is supposed to kind of take that function that scrapes the single website page and then generalize it to multiple websites. But the problem with that is that it wasn't doing what I wanted it to do in the exact sense. So what it really did was that it scraped all these websites in sequence instead of individually allowing me to, kind of manipulate certain aspects of the scrape data and then doing things with them. So this is when I learned about async/await. So I rewrote my code using async await, the async await keywords, and the async await basically gives you a type of imperative feel for your code, and it has the side effect of making it much more readable and easier to deal with. So I also ended up taking it took care of the multiple scraper functionality in a very succinct manner, and this was my code for using the async await. So you'll see on the third and fourth line that those two would have replaced the then that I was previously using, and this actually, does it in a very natural way. So the search for keywords functionality was also fairly straightforward. Again, it was almost a kind of copy of this previous code. We use this previous code, and I wanted to add some context to the scraper after that. So, I really started to think about the Scrappi project on a kind of deeper level, and the description of it was to manipulate time series data. So within this framework of time series data analysis, I figured that a good starting point would be, what could I use, like my background in, say, mathematics and statistics and stuff, in developing an application in the context of something more applicable like marketing and data analytics. So I realized that these features fit nicely within the framework of TF-IDF analysis. So TF-IDF stands for term frequency, inverse document frequency. It measures the importance of a word relative to a corpus, a series of documents. So in this case, our series of documents are like a series of web pages and such. And this is important because it has applications in data mining, user modeling, sentient analysis, and search engine optimization and stuff like that. So, and this has very straightforward uses in business, social sciences, since it lets you understand the user on a deeper level. So, to put it, in a kind of succinct way, it's not so much what you say, but how you say it. And an example of this would be if I, manipulate elements of the DOM such that I'm scraping the review section of an Amazon item, so I can better understand what exactly it is that people like about this product based on occurrences of a certain word, or combinations of certain words that continuously pop up. It gives me some idea and some feel for doing this. So my method was basically to do what I did before. You start with a scraper that scrapes a single website and generalize it to multiple websites. For the single scraper, you keep a tally of the number of times a given word occurs. So the technical term for this is concordance. So how I would, how this would look is that I save it as a type of JSON object where the total text of it is like all the text in the document, and the concordance is like the number of occurrences of these separate items in the document. And the TF-IDF is like what I use in the scraper. So it contains the text and the word count. And next thing to do in the calculations is using TF-IDF. So the reason that we use the term frequency, inverse document frequency, is that counting words alone can get really unwieldy. Like it becomes exponential in a certain type of way, and you need a type of normalizing factor to see the relative merits of the words relative to a document. So there's multiple ways to define the term frequency weight that you use in this, and these are some of them, but I just use the word count as mine. And fortunately for us, Node.js has a library already that calculates the TF-IDF, although it's not necessarily that so involved to do per se. So using like the aforementioned features, it works really nicely under the context of CF, IDF, and service enhanced in various aspects. So previously, what I mentioned was the schedule scraper, which you can view in the code, which is actually quite very trivial because you're just using timeout function. You allow the user to accumulate real-time data from sites such as Twitter, Reddit, etc. Curated data feature allows you to view important words and specific sections of the document, as previously mentioned, like in the Amazon document. And this code snippet is an example of how you would manipulate certain elements of the DOM. So the keyword here is like the asterisk takes all the text, but for instance, if you wanted paragraph tags, you could replace it with P and such, or you could kind of integrate it into your function. I should have probably done that, but it's not that difficult to do. And more advanced features are like visualizing the scrape data through integration with a plotting library and exporting scrape data to a JSON/CSV file and comparing two sections based on similarity of scrape data to see how similar two websites are doing. So I did the first one via Plotly. So Plotly is this type of server-side API that allows me to make really beautiful graphs. And originally I had planned to use the D3JS library, but Plotly also provides me with a really nice way of doing it. And it's also, you know, I don't have to start from scratch if it's already there. So the way to use Plotly is to use the npm manager. So install Plotly, npm install Plotly, and you have to create a username and API key in it, and you initialize the data as such. And from this, you have used the built-in function plot, and you get a URL. It outputs a URL with this beautiful graph. So this is what it plots for. I used Google and Facebook and scrape the data from there. And you can actually go to this website yourself and see like the relevant keywords that it scrapes. And so the last feature at the same time for the advanced features is what inspired me to using the TF-IDF framework, since it ultimately provides a metric to compare how similar different websites are based on the word frequencies. And this is my GitHub comments and stuff. I was a bit slacking on pushing and pulling comments and stuff because I mostly kind of just worked without necessarily pushing to GitHub a lot. And this is an example of me speaking with one of my mentors, Luke, through WhatsApp. Both my mentors were extremely helpful and integral, considering I had no real background in Node. So any questions?
Thanks, Dominic. Luke, do you have any questions?
No, I'm good.
Yeah, so for the purposes of the people who may be listening to the video, could you provide us with just a brief background as to some terminologies that you were using? You had mentioned async versus synchronous methodologies. Could you explain that to us?
Okay, so asynchronous is a type of parallelization. Can you give me a second? Sorry, my roommate is a bit a really heavy sleeper, and it's really inconvenient right now. Yeah, so asynchronous is normally an imperative way of doing programming. You want to do things in sequence. So you start, for loops and while loops are processes where you do things, one after the other. But in web dev and stuff like that, you don't really want to necessarily do things sequentially. Sometimes you want to do things in parallel. So instead of necessarily waiting for a website or an API to give you back data, you kind of wait for it for a while, and if nothing's happening, you'd want to do something else while you're waiting for it. So you can request data from something else while you're waiting for something at the time. And this is very useful. I mean, this is a very useful concept in web dev in general, because you can get stuck a lot if you think of things in a sequential way. If you believe that you need to wait on something first before you do something else. So having this type of kind of parallelism of doing things is really useful for, you know, being more efficient and getting things done quickly.
So give us an example of how you used it in the project.
Okay, so as I mentioned before, I use the async await function. So I made the async keyword makes the function asynchronous in itself, and await basically says that you know, wait on this website, that fetch this website and wait for it to be scraped. But if it's not, if it's going to take too long, like if while it's scraping, don't just stop everything. Scrape another website while you're trying to scrape this website at the same time.
Okay, so in other words, that it provides you with the opportunity to do things in parallel then.
Yeah, exactly. It provides you with opportunities to do things in parallel.
And does that mean that the results from the various websites that you're scraping would then all dump data into the same memory structure, or is it be separate
Yes.
per
Okay.
website?
Actually, this is a very good question because there's two aspects. So how I've implemented it, that it dumps everything into the same, you know, into just like an array or something like that, you know, some temporary variable in which everything is just a big string. But an interesting thing you can do is actually like partition all the like text from into different, like say like a JSON object, and that in itself gives you a new metric for comparing things from different websites. So you can compare how many times like the word say Google appears in Facebook versus Quora, and like if you're scraping certain particular pages of this website. And if you do it with, say, in the way I did it, it's you get everything dumped into one area, and you want to see how important this single word is within like this entire body of documents. But if you want to do it in a more comparative way, you want to say, okay, I want to see how much times this appears in Facebook, and I want to see how much times this appears in, say, Quora or GitHub or something like that. Then that also gives you a new metric for looking at website and kind of analyzing the data. So, I mean, this kind of plays into why I have the JSON, like I added the JSON exporter as a feature, because if you want to have a time series data, like some application that works with time series data, you need, you know, with different ways of looking at the data. You don't really want, you know, just something that kind of works, that you want, you know, you get a lot of information from looking at the data in different ways. And with something like this, you can do it both ways. You can dump everything into like a single object, or you can just, you know, loop through different objects and store it in there.
Okay, thanks. You had mentioned before that you had more of a experience with, I believe you said, an imperative approach to analysis. What do you mean by that?
So, I mean, okay, there's two kind of paradigms. One is functional and one is imperative. So functional programming is functional in the sense of mathematical functions, meaning that when you take an input, you give it an input, it should always return the same output no matter what. So it doesn't necessarily change state. And this is a very, you know, this is extremely useful. This is an extremely useful concept because, you know, sometimes if you're working in industry and production code, changing state is sometimes eludes you. You know, you don't really know that you've done something which changes state, and it's a very nuanced type of thing. But imperative is more, it's more natural to many of us. Like we tend to think of things in an imperative way, in the sense that, okay, do this one thing, after this one thing comes another thing, and after this comes another thing. So we think in that type of sequential way. And the functional approach that like Venn uses is a lot more difficult to get used to, but it is more useful in the sense of like it mitigates the amount of errors that you do have in your code. Like if you're having, say, like 5,000 lines of code and whatnot, a functional approach is very good because you can always track where everything is. Like how it's a lot more difficult to make make mistakes with state and stuff because you don't have to worry about that anymore. And the imperative approach is that and a simple example would be, say, if you're using like C code, like C++ code or something like that, you could create a function that copies everything to a new variable, and then you change the value of this variable within the function, and then it returns something else. In a functional language like, say, Scala or Haskell, something like that is impossible to do. You cannot. The input that you've given always has to return the same output that you get, and that's essentially my approach to, like, I essentially took an imperative approach because the time constraints and stuff, it wasn't necessarily the most first of all, the code is relatively short. It's I can easily see if I made a mistake, I can easily mend it and stuff. But ideally, I would want to go back to this type of functional type of way of coding the scraper.
Okay, thank you. Where do you think the Scrappi could go in future, for like say next year?
Okay, I think Scrappi actually has a lot of potential, and I think because it's necessarily used within the context of statistical analysis, there are many things you can do with it now with reference to data analytics and AI and machine learning and stuff. So, like for instance, one of the problems with Scrappi now is that there's certain like elements, like for instance these kind of strange like the trademark and the C and stuff like that, which you don't really add much to your the data. That you want ways to kind of sanitize the data such that these things don't appear. And using this within like the context of like a neural network or something like that, which can you can train this neural network to just get rid of these things and kind of get a more human feel of what this text is actually saying. I see that using more of these kind of nuanced, like advanced statistical techniques and more AI techniques, Scrappi can go very far. You can, as I mentioned before, you can use this like within market research if you want to understand the user better. You can get a lot out of this with Scrappi if done properly.
Okay, thank you. And I wanted to get some idea from you about what sort of continuous integration / code testing do you think would be necessary for Scrappi, or were you able to do any of that as part of this project?
I would say yes, some, but not on any real meaningful level. So I think that would I think that's something that I would actually I would have to work on, or whoever would be willing to work on Scrappi would have to work on as well, because I don't think it was done on a very rigorous way.
Okay, thank you. Let's see if there's any more questions. Luke, are you sure that you have no more questions?
I can't think of any.
Okay.
Yeah.
All right, thanks.
I think I've asked Luke too many questions like over the past few months already.
That's good to know. All right, Dominic, thank you very much. Luke, thank you very much. I want to thank you for participating in it and having faith in what we were trying to do as a project to help Jamaica. We have many sponsors that are a part of the Calico Challenge, and we thank them all the time about the various types of inputs that they've done to help us to get to this point. We are now in our 4th year. Next year will be our 5th. And I really hope that we can find ways in which we can extend Scrappi and some of these other projects into the indefinite future. Scrappi and Insite and the project that you worked on have been around from the very, very beginning. And so this is now the 4th year of it. And so we should be in a position now where the projects can start to have a life of their own if they can be taken up on by the international community. So once again, thanks a lot. And we'll be posting this on YouTube.
Okay, thank you very much for the opportunity of working with Scrappi. I actually have a very vested interest in it now because I spent so much time with it and see it's this unbridled potential that it has.
Well, let us know, and then we can see whether we can bring in other people to be a part of it.
Okay, I will do.
All right, thanks a lot.